Welcome to Apna study session on CCNA for beginners. My name is Biswadip Goswami and I am currently working with an IT firm in Bangalore. I have more than 9 years of experience in consultancy and content delivery. I have taught more than 9,000 students and I'm a network analyst by profession. Today's session, it will be a very basic introduction on networking. So let us right away start with the basics of the networking and let us see how things are going on. Let me tell you about what things we are going to discuss today, and I'll be giving you a very brief introduction about what is networking and how it works and what are the things you need to know basically to develop an understanding of networking, and then we can move on to different subject contents like the CCNA topics and all those things. So I'll move on to the topic. These are the few topics that we are going to discuss today. The first topic that we'll be starting with, one slide or two slides of introduction to the network. Then we'll have a very small introduction to the information flow, how it works, and what is a network interface card. We'll talk about the TCP and IP, the backbone of the networking. We'll talk about a very small basic protocol, that is the ping protocol. We'll talk about web browsers, web browsing, and how it is related to the network. And the last topic that we'll be covering up very quickly will be the binary representation. So let us start right away by seeing what is a network and what is networking. So let me share my screen here so that you are able to see the introduction to the networking. So networking, the internet, that is the largest data network on earth, as we have been using, as we have like it's a daily part of our lives. So every walk of our life, every single person every day is using networking in one or the other form. It may be human interaction, that is human networking. It may be social networking. It may be a type of mathematical networking. It may be subject oriented networking. It may be physical hardware networking. It may be software networking. It can be anything. So internet is the biggest data network. Internet is connecting our lives. So internet consists of what? It's a multitude of interconnected networks, both large and small. Why multitude of interconnected networks? Because we just don't want to understand what we have. We also want to know and understand what others have. So if we want to share our knowledge, if we want to share our information that we have so that anyone else can be helped with that, for that we need to interconnect multiple networks. Now, connection on the internet can be broken down into physical connection, logical connection, and application connections. So physical connection is what the basic level of network engineers use and handle and troubleshoot. The logical connection layer above that, which is mainly the understanding of the protocols, how it works. An application is basically different web applications, applications like browsers that we will be talking about, which connect, which allows us to see others' information. So that is the upper layer, the crust. A physical connection is made by connecting a specialized expansion card, such as a modem or a network interface card. We'll be talking about the network interface card in a bit, from a computer PC to a network. The physical connection is used to transfer signals between PCs, personal computers, within the local network and to remote devices on the internet. A few more things about networking is like the logical connection uses standard called protocols. These protocols are what? They are basic set of rules and conventions that it is standardized all over the world, so that people follow, that govern how the devices on the network communicate. So suppose I talk in a language which is different than your language, it will be difficult for you to understand, to interpret, to know what I want to express. But if I'm using a language which is something which is common to like 10 or 30 or 50 people, they understand each other well, they can communicate well, and they can share information well. So that is what the protocol does. It gives a standard platform. connections to the internet may use multiple protocols. It cannot be just one protocol. It can be a variety of type of interactions that we do through the internetworks. The applications that interprets the data and displays the information in an understandable form is the part of the connection. So whenever we are connecting, whenever we are interacting over the network, what we do is we share data, we gather data, we share data, we try to interpret the data, we try to understand the data and make it into information. So the level of basically flow of information basically starts from where we call it as the data. So the first level is the data, which we get it in the raw format. This is basically a raw form, and then we make multiple data. We bring together multiple data, we combine multiple data and format it as a information. And this information, it may be useful at this current point of time, or it may be useful at a later point of time. So you store it, and when required, you process it and give it to others. That is what is called knowledge. So data, information, knowledge. And when you keep it for a long period of time and you store it and you try to like harness it, process it, and use it in multiple ways, it is called wisdom. So these are the different like flow of the data, and this is how basically people work, interaction work in the network, the field of network. So applications work with protocols to send and receive the data across the internet. What happens actually is the internet is a collection of multiple devices. It is not just one device, it will be multiple devices, multiple types of device. Like you can have a personal computer, you can have a laptop, you can have a digital pad, you can have a mobile phone, you can have a refrigerator which is digitally connected to the internet, you can have a car which is running on network instructions. And when you connect all of them together, every application work with protocols, sending and communicating with data with each other, communicating over the network. So there is where the application will be working. So application is just a graphical user interface which communicates or sends and receives the data through some standard set of rules. That is what the protocols are. A web browser is such an application. So it displays what? It displays the hypertext markup language, which is commonly known as the HTML, as a web page. So web page is something which we very commonly, very often see. And another protocol very commonly used is the file transfer protocol, which is used for downloading files and programs from the internet. When we try to download a music file, we must be using YouTube videos. So when we use the YouTube video for our reference, we try to cache it, download it and cache it, or keep it in our PC for a shorter duration of time. We also try to download notes, the PDF files, the text files, which we share and try to receive from our instructors, from our schools, our colleges. We try to share knowledge over Word files, PowerPoint presentations, and so on. So these are different files, type of files, which are generally transferred over the file transfer protocol. Now, next is information flow. Information flows in electronic form. So information and electronic power are constantly flowing in a computer. That is why we need a live point where you can plug in your PC point and you can switch it on and you can get electricity. If you don't have electricity, your computers, your basic needed everyday devices will not work. So that is why we need power, you can say power sources like batteries. That's why mobile phones have batteries. So information and electrical powers go hand in hand. Outgoing and exported information flows from RAM and the CPU, the random access memory, and the CPU, the central processing unit, through the bus and the expansion slots. As you can see in the diagram here, you have a small CPU unit, a memory unit, a storage unit, and the interfaces. The interfaces are like the mouse, keyboard, monitor, and others, and the network interface card. You have the storage units, like you may have a external drive, a CD-ROM, a tape drive, a floppy drive, a hard disk, etc. You may have an internal storage device, which is permanent storage of the information, like read-only memory. You can have a volatile memory, like a random access memory. You can have a flash memory. You can have an EEPROM. So you have a processor to process, but all of these need power to run. And all of them are connected centrally to something called as a bus. So outgoing and exported information flows from the RAM and the CPU through the bus and expansion slots to the printer, video card, sound card, and network interface card. Next is what might be a network interface card. We have been talking on the very first slide, very first introduction, that there is something called as a NIC, or the network interface card, or an Ethernet card, or a LAN adapter. So multiple names, but one single thing it does. It is a printed circuit board, a PCB, that provides network communication capabilities to and from a personal computer. It's a small chip. It's a small circuit board which has multiple chips on them, multiple small circuits are there, electronic circuits are there, which store information which is in electrical format, and it tries to communicate with multiple devices like an external router, an external switch, an external modem, with the internal PC. So PC is the one which carries this one, and it tries to communicate with the external hardware. And it is also called as a LAN adapter. Why LAN adapter? Because it's a local area network device. It is directly connected into your personal computer. So if you want to communicate from your personal computer to external device, you need to have a LAN adapter, and it resides in a slot on the motherboard and provides an interface connection to the network media. Now, when selecting a network interface card, you can see in the image where it fits in. It's a very old PC style, but new PCs also have the same way. They are available in the motherboard. They are available onboarded on the motherboard. They are integrated on the motherboard, because they don't want you to buy separately a network interface card until and unless it is damaged while you are using it. So when selecting a network interface card, there are the following factors which you need to keep in mind, like the type of system bus, whether it's a PCI bus or a ISA bus, the type of media, whether it's using a coaxial fiber cable, or a fiber optic cable, or a wireless card adapter, or a twisted pair cable, what goes connected to that particular NIC, and what kind of protocols it supports. Because when you are connected to the internet, you have multiple protocols and pictures. So does it support all of them, like Ethernet, token ring, or FDDI, or it only supports Ethernet? What is the amount of data it can handle? Maximum 10 Mbps, 100 Mbps, 1 Gbps, etc. We'll talk about all of these in the later part of the sessions. Next comes a very, very, very important backbone protocol of the network, which is called the TCPIP. That is Transmission Control Protocol and Internet Protocol. A very detailed description will be discussed when we are doing with the actual sessions in the CCNA classes. That time we'll be discussing about the TCPIP, what it is, what is the stack about, how the headers look like, what kind of payload it can have, and all these things. But for the time being, we'll just understand where it is and how we can find it and what it does. So Transmission Control Protocol, or the Internet Protocol, it is a set of protocol or rules developed to allow cooperating computers to share resources across the network. So if your computer and your friend's computer are on the same network, or they are directly connected using the LAN cable, you want to share some amount of data, you have to make sure this TCP/IP is enabled. It should be available, it should be installed. More or less all of the operating systems support this one, but you have to make sure it is installed properly, it is available for use. Because if it is not, you'll not be able to transfer any data, you'll not be able to do any network communication. To enable TCP/IP on the workstation, it must be configured using the operating system tools. All these things are available when we will be talking about the CCNA session. Next is another important protocol, which is just to check whether a device is alive on the network or not. So ping, it is a utility used to verify internet connectivity. The ping command works by sending multiple IP packets to a specified destination. Each packet sent is a request for a reply. So what it does, it tries to send something called as an echo packet. I'll write it down here for you. So whenever you send out a packet, there are a few things which are related to this ping, like the time to live for the ping, the round trip time and how many packets are sent out. So we are talking about the echo packet. This echo packet or the ping packet, generally the default number of packets which are sent when you use this protocol is 4 packets. Okay, but you can always increase the amount of the count or the number of packets which you want to send, because over a period of time you will be having 3 different values. One which is called the average time, one which is called the minimum time, and one which is called the maximum time to go and come back to the source. Whenever we are talking in a network term, we talk in terms of source and destination. So our packets generating from the source should come back to the source with a particular time taken. So that particular time is called the round trip time, and there are something called as average time taken, minimum time, and the maximum time. So all these things are taken care when you do a ping test, whether the device is alive or not, and if it is alive, how much time actually it is taking. Okay. Next is the ping command. It is used to test the NIC transmit receive function and the TCPIP configuration and network connectivity. A few more things about ping. The output response for a ping contains the success ratio, the round trip time to the destination. From this information, it is possible to determine if this connectivity to a destination is good or not. You can see from the example given here, the TTL, the time to live, the time taken, the bytes sent, and the reply from. So this is basically an IP address. We'll be talking about all these IP addresses and type of IP address and what is the specific IP address and all in the upcoming chapters. But for the timing, just understand that when we try to test our own system, whether our PC is connected to the network or not, whether it is healthy or not, we do a health check using this ping. So we ping to the 127.0.0.1. We check whether all the packets are coming back or not. If not, there is some issue with the outgoing flow of the information, or else everything is good. Next, we are going to talk about web browsers. What is this web browser and how they are useful? Two of the most popular web browsers are Internet Explorer and Netscape Navigator, or Netscape Communicator. So what is this browser? It's a software that interprets or understands or accepts, reads, and make us understand what the HTML language talks to us. Okay, so HTML, or the hypertext markup language, if you see the markup language, you will not understand anything, because generally it looks like this. It will have tags like HTML, and it will have closing tags, but what is there inside it and how we want to see it, that will be what this interpretation of this particular software, application software, does. So that there is where this browser is required. So what are the functionalities of this browser? It contacts a web server, it requests information, it receives information, and it displays the result on the screen. So as we see here, it's a total network communication with one device with another device. We have a source, which is our PC. We have a destination, which is a web server. Our PC tries to communicate or request information from the web browser, the destination. The destination understands what it requires and it sends back the information to the PC, so it receives the information, and finally it displays the result on the screen. This is how the whole network communication works. So not just a browser will be able to show you pages, but also it will be able to display flash information, flash files, macromedia flash files, videos, audios, through these applications which are called plugins. So what are these plugins? There are also many special or proprietary file types that standard web browsers are not able to display. To view these files, the browser must be configured to use the plugin application. These applications work in conjunction with the browser to launch the program, like Flash. One example is the Flash, which plays media files. So most of the time we have seen students playing online games and using chat windows on online. So all these are created in some language, Java language, and or maybe some other language which they must be using, and then they are used through this flash interface. You are creating a video with a handy cam with a mobile phone, but when you upload, it is converted to a particular format, and then you will be able to like play it with a QuickTime player or a real-time player. You can listen to music online. Now, a very important part of networking is to understand the binary representation. The reason being, computers work with and store data using electronic switches that are either on or off. Okay, computers can only understand and use data that is in these two states or binary format. One is represented by on state, zero by a off state. Ones and zeros are referred to as binary digits or bits. A binary zero might be represented by 0 volt. So generally, when we talk about a 0 bit, that is a 0 volt, and 1 bit or a single bit with a 1 value, that will be a +5 volt. This is how they are represented and stored in the small circuits. There are multiple circuits. We'll also talk about the circuits later, which store them, which try to which we try to use as memory, as a temporary storage, like cache memory, what we have heard about. We have talked about RAM, ROM. These are all basically storing what? These are storing ones and zeros. How they are partitioned, sectors, different formats are done on the hard drive. Sectors are there, segments are there. So we'll be talking about them later. For the time being, we'll just understand, okay, so this is what is needed to be understood, ones and zeros. Now, the whole language, binary language, they work on bits and bytes. Computers are designed to use groupings of 8 bits. This grouping of 8-bit is referred to as a byte. So whenever we talk of a string, of a word, of a particular sentence, of a particular paragraph, they are nothing but broken down into bytes. Okay, there is a complete other language in computer terms. I'll show you what the language is called. The language is called ASCII. Okay, ASCII language. I have a complete sheet about it. I'll talk about that in a different session. But this ASCII language is what helps computers understand what these bytes actually mean, and they make us understand. So when they store it, they'll just store it blankly. But when they have to process it and display it to us, they'll be using the ASCII chart. They'll be using the lookup value from there. They'll be taking it and displaying it accordingly. So complete characters will be sequenced with even space, full stop, exclamation, hash, question mark, comma, underline, everything will be there. So this grouping of 8 bits is referred to as a byte. This byte, single byte, 8-bit, in a computer, this represents a single addressable storage location. We are not going into details of how they are stored, what this storage looks like, but for the time being, we'll just know about this, that 1 byte represents a single addressable area. These storage locations represent a value or a single character of data. The total number of combination of 8 switches being turned on is 256. The value range is 0 to 255. I have a complete sheet of how the bytes are actually used and what are the different combinations turn out to be, how we do the numbering of binary to decimal and decimal to binary. In a different session, we'll be discussing about that, not right now. So the total number of combination come out to be 256, and the value ranges from 0 to 255. Coming to the last part, that is bits, bytes, kilobytes, megabytes, gigabytes, terabytes. This is how the calculation works out. You have bit, which is a 1 or a 0. You have byte, which is 8 bits. You have kilobyte, which is 1024 bytes, or approximately 1000 bytes. And we have megabyte, approximately 1 million bytes. We have gigabyte, which is approximately 1 billion bytes. We have terabyte, approximately 1 trillion bytes. Now, if you can tell me how many bits are there in a megabyte, I'll show you the calculation, but this will be the last part of it. So how many bits are in a megabyte? We have 1 million multiplied by 8 bits. That's all the calculation you can do here. It's a very big number. You don't have to remember it. anything you don't have to remember, any numbers you don't have to remember here, but you should know how to find the calculation. You should know how to find the numbers here, what they are storing, how they are storing. You don't have to even remember the ASCII codes, but continuously working for a very long period of time, you will start remembering things. You'll start understanding things, and you will know how to memorize them. Okay, so that's it for today from my side, and in the next session we'll see what we have for you, maybe a little more about what are the protocols we have. We'll talk about different devices in networking, like routers, switches, and what they are like, how they work, and the basics of communication in the routers, in the switches, what are the protocols they use, a higher level of networking, what is secure, what kind of security does this Cisco products provide, what is the firewall, basic understanding of all these things we'll be talking about. So that's it from my side today, and thank you and have a very nice day. I'll stop sharing, and you may also like to have these sessions recorded, and you can just go through them later on, and you may just continue reading. Okay, all the best. Thank you.